Hey everyone! In this video, I'd like to take a look at how to find the derivative of functions that involve some of our other trig functions. So these functions are going to involve tangent, cotangent, secant, and cosecant. So first of all, let's just run through the theorems that allow us to find these derivatives. So let's start with the two main ones. So we have a theorem that says that the derivative of the sine of x is equal to the cosine of x. And we have a very similar one that says that the derivative of cosine is equal to the opposite of the sine of x. Once we establish these two, we can actually use these along with our trig identities and the quotient rule for derivatives to find the derivatives of the rest of our trig functions. So to explain what I mean, let's think about the derivative of the tangent of x. So the tangent of x can be written as sine divided by cosine. So that's using one of our trig identities. Once I have this written as sine divided by cosine, I can use the quotient rule for derivatives to find out that the derivative of tangent is equal to the secant squared of x. And in a similar way, I can find the derivative of cotangent. Cotangent is the same as cosine divided by sine. And then using the quotient rule for derivatives on that, we figure out that the derivative of cotangent is equal to the opposite of the cosecant squared of x. And our last two, so the derivative of secant of x, so secant is equal to 1 over cosine. This is going to be equal to the secant of x times the tangent of x. And the last one, the derivative of cosecant of x, we end up with negative cosecant of x cotangent of x. So taking a look at these, there is some relationships between them. So the first one, something that can help us out, is the derivatives of all of our cofunctions. So any of these that start with the letter c, so cosine, cotangent, cosecant, the derivative of each of those has a negative sign in it. So negative sine of x, negative cosecant squared of x, negative cosecant times cotangent. The other thing to note is the relationship between the two cofunctions. So if I look at sine of x and cosine of x, and I compare the derivatives, they kind of have switched trig functions. The same thing applies for our other ones. Tangent and cotangent are cofunctions. And if I look at the derivatives are cofunctions as well. So now that we have these established, let's use these in some examples. So my first example, I have a function f of x is equal to the tangent of x divided by x. So we're going to need to use the quotient rule to find the derivative here. So let me just jot down the quotient rule again. So if I have a function written as a quotient of two other functions, we have the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over our denominator squared. So going back to our function here, let's find f prime of x. So following along with our quotient rule, the derivative of the numerator, so the derivative of tangent of x, we just saw that this is equal to the secant squared of x. And we're going to multiply this by our denominator, which was x. And then we're going to subtract the derivative of the denominator, so the derivative of x is just 1, times our numerator of tangent of x. And this will be all over our denominator squared, so x squared. And then just to rewrite this, so our derivative, f prime of x, is equal to x times the secant squared of x minus the tangent of x all over x squared. And that's it. So here's our derivative using the quotient rule. And why don't we do one more example with a different trig function. So So our last one, g of x, is equal to x squared times the secant of x. So in this case, I have two different parts here, and they're being multiplied together. So I'm going to need to use the product rule. So just as a reminder, the product rule, if I have a function that can be written as the product of two other functions, it's the first piece times the derivative of the second plus the derivative of the first times the second. So going back to our function g prime of x, this is going to be equal to, so our first piece, so x squared, times the derivative of the second piece, so the derivative of secant is equal to secant of x times the tangent. And then we're going to add the derivative of the first piece, so the derivative of x squared, using the power rule, we get 2x, times that second piece, which is the secant of x. And to finish this one up, why don't we factor out an x and a secant from each of those terms? So g prime of x, let's write this as we have x secant of x, and that's going to be times, and we are left with x tangent of x from that first term, and we're left with 2 from that second term. So in this case, just an alternate form to write this in, but here's the derivative of the function g using the product rule.